Welcome back, students. Today let us continue to solve the problems on chapter Polynomial.
What is zeros of the polynomial? Yes, zeros of the polynomial is that value of x which makes the polynomial 0. That is p of x is equal to 0. If p of a is equal to 0, then a is the 0 of the polynomial. Right? Now let us try to solve some more problems on zeros of the polynomial. Find the zeros of the polynomial p of x is equal to 2x minus 4. First we have to equate the given polynomial into 0. That is p of x is equal to 0. Now substitute the value of p of x. What is p of x? It is a linear polynomial. That is 2x minus 4 is equal to 0. Now we have to find out what is the value of x, on which value of x the given polynomial becomes 0. Therefore we have to find out the value of x. So 2x is equal to what? Minus 4 or plus 4? Yes, it is plus 4 because minus 4 when jump to other side it becomes plus 4. So x is equal to 4 divided by 2. So x is equal to, simplify, you will get 2. Therefore 0 of the given polynomial is equal to 2. So see, in this problem given polynomial is a linear polynomial. P of x is equal to 2x plus 4 or 2x minus 4 is an example for linear polynomial. So it has only one 0. Remember why it is so? Because the degree of this linear polynomial is 1. See here, x raised to the power 1. So it has only 1 0. That is what? It is 2 in this case. Now let us find one more 0 in another problem. Find zeros of the polynomial p of x is equal to x square plus 3x plus 2. See, this is one quadratic polynomial. This is an example for quadratic polynomial. So, how many zeros should it have? Yes, let us try. First, equate this problem. Equate p of x is equal to 0. Now substitute. P of x is equal to what? It is a quadratic polynomial. X square plus 3x plus 2. Equate it into 0. Since this is a trinomial or quadratic polynomial, what is the how can you factorize this trinomial? Product of first and last term, x square into 2, x square into 2 is equal to what? 2x square. Now sum, it should give sum as 3. What are the two numbers? When it multiplies, you should get 2 and sum as 3. Yes, correct. 2 and 1. 2 ones are 2 and sum of that two numbers equal to 3x. 3. So 2x and 1x are the two numbers. So x square. Now split 3x into 2x plus 1x or x and write the final last constant, that is 2, is equal to 0. How can you simplify further? Factorize by grouping the terms. On taking common factor outside, x is the common factor, take outside. What's remaining here? X plus here, this is 2. Yes, similarly here also you should get the same term inside the bracket. So what should I keep outside the bracket? x, already x is here. On multiplication with 1, we will get the x plus 2 bracket, right? So now again, what's common here? X plus 2 is common, take outside, and what's remaining here? X, and here plus 1, that's equal to 0. Therefore either x plus 2 is equal to 0 or x plus 1 is equal to 0. That implies what? X is equal to carry plus 2 into other side, it becomes minus 2. Here x is equal to minus 1. So what are the two zeros? Zeros are minus 2 and minus 1, right? So this is an example to find zeros of the quadratic polynomial. Since its power or degree is 2, so children, let us find zeros of the polynomial f of x is equal to x square minus x minus 6. F of x is given, so equate it into 0 first. Therefore f of x, what is the value of f of x? It is x square minus x minus 6 is equal to 0. Factorize the trinomial in this way. Product of first and last term is equal to minus 6x square. Now on multiplication of which numbers will we get 6 as the product and difference as middle term, that is 1. Which are the two numbers? 2 and 3. Yes, 2 3s are 6 and difference of 3 and 2 is 1. Therefore these numbers holds good, but negative sign implies what? Either 2 or 3 must have negative sign, and larger number, because the middle number has a negative sign, therefore put negative sign to larger number. Therefore we can write x square as it is and split minus x into plus 2x minus 3x. Keep last term minus 6 as it is. Now take the common factor outside. X is the common factor. Inside the bracket, what's remaining? X plus 2. Again, write the same bracket x plus 2. We have to keep minus 3 outside the bracket. Now, again x plus 2 is the common factor. X minus 3 are remaining here. Therefore, this implies either x plus 2 is equal to 0 or x minus 3 is equal to 0. So, x is equal to minus 2 and here x is equal to minus 3 becomes plus 3. Therefore, zeros are minus 2 and 3. These are the two zeros. Since its degree is 2, therefore we have two zeros. If f of x is equal to x square minus 3x, find its zeros. Yes, equate first into 0. F of x is equal to 0. What is f of x? X square minus 3x, that's equal to 0. So take common factor now. X is the common factor. So what are remaining inside the bracket? X minus 3, that's equal to 0. This implies either x is equal to 0 or x minus 3 is equal to 0. That means x is equal to 3. So zeros are, what are the two values? They are zeros. Zeros are 0 and 3. These are the two zeros. Now let us go to next problem. Check whether 3 and minus 3 are zeros of the polynomial x plus 3. Since x plus 3 is a linear polynomial, it should have only one 0. Therefore, either 3 or minus 3 may be a 0. So, first take P of x is equal to x plus 3, and what are the values of x here? It is given 3 and minus 3. First now substitute x as 3. So P of 3 is equal to x value 3 plus 3 is equal to 6. Again, is it a 0? No, because when you get 0 as the answer, then it is said to be 3 is said to be 0 of the polynomial. Now again substitute x as minus 3. What do you get? Minus 3 plus 6 in the polynomial. We will get plus 3 minus 3 gets cancelled. We will get 0 as the answer. Therefore, whenever you get 0 as the answer, means P of x is equal to 0, then the value of x is said to be 0 of the polynomial. Therefore, minus 3 is the 0 of the given polynomial, right? Children, now some important notes in front of your screen. Let me read one by one. Every linear polynomial in one variable has a unique 0, means it has only one 0, and its degree we know is 1. A quadratic polynomial has at most 2 zeros, means maximum it contains 2 zeros, and its degree is 2. A cubic polynomial has at most 3 zeros and its degree is 3. Any constant polynomial has no zero and its degree is 0. A zero polynomial's 0 is not defined. Yes, children, can you recall the relationship between remainder, quotient, divisor and the dividend? Yes, you are right. It is given by dividend is equal to divisor into quotient plus remainder. If we apply the same into two polynomials p of x and g of x, then we will get some quotient q of x and remainder r of x. Then it is given by p of x is equal to g of x into q of x plus r of x. Now one problem is shown here. Divide the polynomial p of x is equal to x plus 3x square minus 2 and g of x is equal to 1 plus x. Can you divide this? Okay. I will give one simple problem. 12 divided by 3. Now can you divide? Yes, all of you. You can divide this. 12 divided by 3 is equal to 3 4s are 12. That's equal to 0. So, we will get quotient q of x in this case is equal to 4 and remainder r of x is equal to 0. Right? Now, if you get 0 as the remainder, then we can say 3 is the factor. 3 is the factor of given number, factor of dividend, factor of 12. Also, we can say 12 is the multiple of, it is the multiple of 3 also, right? Okay, remember. Now, I will solve this problem. See, divide p of x by g of x. P of x is given. It is not in the standard form. Write down it in the standard form. 3x square plus x minus 2 and g of x is equal to, it is also not in the standard form. Write down in the standard form. Now divide 3x square plus x minus 2 divided by x plus 1. Now dividends first term write down here and divisors first term, divide by x, it is the first term. x 1 gets cancelled. Now you will get 3x as the quotient. I will write 3x here, it is the quotient. Now multiply 3x with each term of divisor. 3x into x becomes what? 3x square. Again 3x into 1 becomes plus 3x. Now subtract. What is the rule? On subtracting, second term's sign will be changed. Plus becomes minus. Here also plus becomes minus. Plus 3x square minus 3x square gets cancelled. Here what is remaining here? Minus 2x. Now carry minus 2 here. Again dividends first term divided by divisors first term. You will get minus 2 as the quotient. Write down minus 2 here. Again take multiply minus 2 with x and multiply minus 2 with the plus 1. Minus 2 into x becomes minus 2x. Similarly minus 2 into plus 1 is equal to minus 2. Now subtract. Sign will be changed. Second term's sign, it is already now minus, it becomes plus. Here also it becomes plus. Minus 2x plus 2x gets cancelled. Plus 2x minus 2x gets cancelled. So remainder is what? 0. Therefore q of x is equal to, where is the q of x? Quotient. At the top we can see 3x minus 2 as the quotient, and remainder at the bottom we will get the remainder and it is 0. Now can you say x plus 1 is one of the factor of 3x square plus x minus 2? Yes, you are right. Therefore we can also say x plus 1 is the factor of given dividend 3x square plus x minus 2. And can we say the dividend 3x square plus x minus 2 is multiple of x plus 1? It is also correct. So 3x square plus x minus 2 is the multiple of x plus 1 also, right? This is also important. Okay, now I hope you all are got this problem, right? Okay, now let us move to one more problem. Yes, before going to this, remainder theorem. Let us see what is remainder theorem. Any polynomial p of x is divided by a linear polynomial x minus a, then the remainder is p of a, where p of x be any polynomial of degree greater than or equal to 1 and a be any real number, right? This is known as remainder theorem, and you need not bother about this remainder theorem. Just see how can I simplify or find out the remainder in this problem, right? Yes, p of x is equal to x power 4 plus x cube minus 2x square plus x plus 1, and g of x is equal to x minus 1. Find the remainder. What is the remainder? Without actual division, using remainder theorem we can find the remainder. See, this is very simple. First we have to write g of x is equal to x minus 1, equate it into 0. G of x is equal to 0 means what? G of x is x minus 1 is equal to 0. Therefore what is the value of x? X is 1. So now in the given polynomial p of x Substitute the value of x by 1. Now, what is p of 1? Substitute the value of x by 1. So, 1 power 4 plus 1 cube minus 2 into 1 square plus 1 plus 1. It is equal to 1 power 4 means what? 1 power 4 is equal to 1 into 1 into 1 into 1. What's the product? 1 1 is 1, 1 1 is 1, 1 1 is 1. So, product is 1. Again, 1 cube. It is also 1 into 1 into 1 is equal to 1. Now, minus 2 into 1 square. 1 square is 1. 2 1s are 1. Minus 2 plus 1 plus 2, 1. It becomes plus 2. Now, what is the answer? Plus 1 plus 1. Here, 2 minus 2 plus 2 cancelled. So, p of 1 is the remainder. Therefore, remainder is equal to 2. See, without actual long division method, we can also find out the remainder using the remainder theorem. This is simple, no? Yes. How can we verify this? Whether it is correct or wrong? How can we check this? Yes. We can simplify the previous problem. Find the remainder of the previous polynomial by using remainder theorem. We already found remainder as 0. In the particular case, p of x is equal to, it is given p of x, I will write now, p of x is equal to x plus 3x square minus 1. It is the previous problem, and g of x is equal to 1 plus x. This is 3x square minus 2. This is 1 plus x, right? Now, without actual long division, we can find out the remainder. Now, equate g of x into 0. G of x is equal to 0. G of x is what? 1 plus x is equal to 0. So, x is equal to plus 1. When moves to other side becomes minus 1. So, apply or substitute x value as minus 1 in this polynomial. It becomes x means minus 1 plus 3 into value of x is minus 1. Its square, whole square, minus 2. Now, minus 1 plus 3 into minus 1 becomes what? Minus 1 square means minus 1 into minus 1. It is what? Plus 1. So, 3 into 1 minus 2. Now, minus 1. 3 ones are 3 minus 2. It becomes 3. Minus 1 minus 2 becomes minus 3. Now, what's your answer? Plus 3 minus 3 gets cancelled. Answer is 0. So, remainder is 0. Right now, we verified already. We verified 0 is the remainder in the previous problem.